Basically, let's start with our topic of probability and various distributions. Probability is basically an uncertainty to a prediction system. Whenever in our daily life we come across various uncertain situations and there is impossible outcomes of that situation that was predicted by our tool called probability. A journey from awareness to understanding where chances become measurable and uncertainty transform into insights. And our daily life just we are measurable and uncertainty transform into insights, and there are many randomness in our life where we are just getting messed up and we are don't have any kind of um, there is such an outcomes of that events. Basically, all those decision making in our life, in the terms of probabilities, are called events. Basically, in these events, we are just came across a randomness to understanding where the chances become measurable or an uncertainty transformed into insights. So let's understand what how the beginning of this came across. So every day we navigate that worlds are filled with uncertainty. Like we have various questions across us that we in our daily life, that will it be rain tomorrow, or will the bus arrive on time, or whether we are going to catch the train or we are going to miss that flight. Or how many customer visit a shop today. So this question seems unpredictable, and yet patterns emerges when we look closely enough. So probability theory gives us a tool and quantify uncertainty and transforming the chaos of random events into a structured understanding. So it's a bridge between not knowing and making informed predictions. All the extract of this slide is that in our world, because we all knew that the nature is unpredictable, so to certain unpredictable things there are a pattern observes of a rain, pattern observe of a weather conditions, pattern observe for a timings of all the transport systems. So this are uncertain situations. So to deal with uncertainty and to get know about this uncertainty, we have a probability theory which has its tool to quantify the uncertainty and transforming all the chaos of random events into a structure for understanding, so that we can make a good decision and we make a prediction, and that will apply a profit for us. So let's understand what's probability. So whenever a situation occurs where an event is happen, there is that event is going to happen or event is not going to happen. There are two possibilities. So these possibilities are expressed in a number which is between 0 and 1. 0 means it's impossible to occur for occurring of an event, and 1 means that a certain possibility that event is going to happen. And the range between 0 and 1 gives the measurement of the events occurring. So the formula of probability is number of favorable outcomes upon total number of possible outcomes. This we have a dice that if we roll a dice, how many, what is the possibility of coming off of one number. So in this dice we have a situation I call we have the uncertainty of a number 1. So that's why we are applying this formula where the number of favorable outcomes upon total number of possible outcomes. So before going to probability, we just have to understand the essential terminology of this probability. So in probability, we have a four terminologies: experiment, outcome, sample space, and event. So what is experiment? Basically, any procedure that can be repeated and has a well-defined possible outcomes. It is called experiment. For example, if we are experimenting on a situation of a student who are studying or not studying, so we have repetitive questions, and we all have a well-defined possible outcomes, like he is studying or he is not studying. So basically this is called experiment. Second is outcome. For example, if we are rolling a dice, single result from an experiment, and rolling a 4 on a dice, just we have a fixed result which is 4, and we are just rolling a dice, we are experimenting, we are rolling a dice and it is an experiment right? Rolling a dice is an experiment, and there's single results we are focusing on, which is 4, which is called outcome. Then sample space. So whenever the number is so large, for example, we have hundred thousands of people, and we create a sample space of hundred of people, so that we can set a possible outcomes in an experiment in a sample space. Second is the event. For example, for which event a specific outcome or collection of outcomes are interested in is called an event. For example, it is raining or not raining. So basically raining is an event, and it has a specific outcome that it will rain today or it will not rain today. So these are the essential terminologies of probability. So the three flavors of probability. We have a classical probability, we have empirical probability, and we have a subject probability. The classical probability basically in this that we have equal number of outcomes, and the total numbers of favorable outcomes are known to us. For example, the perfect example is probability of rolling a 3 on a fair dice. We in a probability of rolling a dice. In this event we have a known numbers of total numbers of outcomes, which is 6, and just we are focusing on one event, which is 3. So basically it's a classical probability, and it's perfect for games of chance like rolling a dice or drawing cards, where all outcomes have equal probability, which is 1 by 6. This is called classical probability. If we are just focusing on 2, it also has a probability of 1 by 6. This is called classical probability. Just now we are focusing on empirical probability. So based on observed frequency from experiment or historical data, we just came across a situation, and we have came across a prediction, which is called empirical probability. For example, when the sample space is so large, for example, how we are starting our on shopping online shopping industry, which is called and we have thousands of customers in which purchase online, and we have 300 out of 1000 customer which purchase online. So the empirical probability is 0.3, which is came across historical data that we have a 1000 customer in which 300 are purchased online, and we have exact known of this data which we collected from our experiment. Third one is subjective probability. So subjective probability is based on personal judgment, which do not have any kind of number formal calculation, but it has intuitions or expertise, or just we predict like doctor estimating a patient recovery chance based on an experience. Doctor can predict the patient recovery time by its experience, and this is a subjective probability. So let's understand the gateway of distribution. We all knew that the probability has its own distribution and its own multiple traits. So we entered the realm of a probability distribution, which has its mathematical functions that describe how probability is spread across all possible outcomes whenever the outcomes are more. And distribution, basically probability is just a theory, but distribution allow us to model the real world phenomenon systematically, and predicting not just single event but entire patterns of the behavior. And this is the gateway of distribution, where we understand how the distribution is going to happen, and it allows us to model a real world phenomenon systematically and predicting not just single event but entire pattern of behavior of that particular event. So we have this discrete distribution, what outcomes are countables. So discrete distribution applies when outcomes can be counted. Whenever a situation event occurs, when the whenever the outcomes can be counted. For example, if we are rolling a dice, we all knew that outcomes are 6. We are when we cross a coin, number of heads in a coin, we all knew that there is one head and one tail in a coin. So this are the countable outcomes, and customer arriving per hour, defective items in batch, and each outcome is a specific probability, and we can list them all. So this probability is distributed. We have a normal distributions, which is Bernoulli's distribution, in which a model a single trail with two outcomes, success or failure. In Bernoulli's distribution, we have one success or failure, which is all a single trail. And in binomial distribution, we the model depend number of success in a fixed number of independent trials. Like we have decided a fixed number of independent trials, and we just train a model which order number of success. For example, um, we have a customer arriving per hour. So we all that customer are purchasing, or customer is not purchasing in a fixed hour, which is fixed number, which is in 60 minutes. And third one is Poisson distribution, where the model the number of event occurring in a fixed interval of a time or space. Thus I have already mentioned the customer arriving per hour. So Bernoulli is in binomial, the coin toss theory. So in Bernoulli distribution, we have a single trail. For example, if we flip a coin, either we have outcome of head or we have a tail. So one free throw in a basketball, either you have make a probability of 0.7, or if you miss it, you have a probability of 0.3. So binomial distribution means multiple independent trials. For example, if we flip a coin only 10 times, and how many head will appear? So we're taking a 10 free throws. So what is the probability of making exactly 7? So that was the binomial distribution when we are doing the single twist multiple times. And when we came across the Poisson distribution, they are rare events over times. For example, customer arrival. Customer can arrive in a fixed time period of per hour. So we have a 5 customer per hour. So to calculate the exactly the 3 arrive, what is the probability of exactly 3 arrive in an hour next hour? So there's a prediction may came across the Poisson distribution. Third one is email frequency. You are receiving an average of 8 emails per day. So how likely you get 10 tomorrow? Third one is emergency call. A hospital receives 2 emergency calls per night on average. So predicted to night volume. And so this whenever the time frame constraint are there, there is probability distribution is there. So the formula of probability distribution is lambda is raised to the power k into e raised to the power minus lambda upon k factorial. Well, lambda is average rate of occurrence. For example, 5 customer per hour, so the lambda is equals to 5, and k is the number of outcomes what exactly we want. It's just 3, and e is our exponential of minus lambda, and the factorial of k is which is equal to 3 is 3 into 2 into 1. So continuous distribution, the normal curve. So when outcome can take any value within a range, height, temperature, exam scores, we use continuous distribution. So whenever a range is came, we use continuous distribution, and a normal Gaussian distribution is the most important and appearing rare in nature and society. For example, within one standard deviation, the data falls within plus 1 to -1 of the mean. We all know the mean is the most occurring frequency, and mean, which is called average. And with 2 standard deviation, we have -2 to +2, which is 95%. And with 3 standard deviation, our data falls within -3 to +3, and which is gives us 99.7% accuracy. So in real example, the human heights, IQ scores, measurement errors, exam results, and countless natural phenomena are calculated by continuous distribution, which is fall on standard deviations and standard deviations. This is all about the probability of which we are just going to happen. If you have any of the doubt, you can contact or you can mail me personally or in the comment section. So like, share the video and subscribe it, and be with us for this such kind of informational videos based on our nature, our prediction, and the uncertainty between the events of probability and its distribution. And if you have any of the questions, you can ask me in the comment section. I will happy to answer you all. So like the video guys, subscribe it and share it across with who need it. Thank you.